Alrighty, CNT120, we're looking at the next little chunk of our Chap3Lab. We're going to look at the Netstat command. Now, Netstat is going to show any sort of network statistics about our system. So if I start off with just a Netstat command and a question mark, this will show me all the options. And this is a handy little tip to know on just about any command. If I do a Netstat or, the command and a question mark oftentimes on Windows, it'll show me all the options I can do with it. If I just do a plain Netstat, it'll show me the statistics on any active connections that my machine has. So the first handful I see are loopback, and then I'm going to see a couple with 172 of active connections that are running. And this looks like some sort of Microsoft or Microsoft Network MSN system running and updating and so forth. This actually shows any active connections. Now, this is handy for looking at data flowing in and out of my machine, and you'll see it's an IP address followed by a port number. So if you remember looking at addressing before and port numbers, this talks about, or this shows the active connection to that particular IP address in that port number. I can also look at Netstat-A, anything it possibly knows about my system here, and it'll show that. And I'm seeing quite a bit more information now. I'm seeing specific TCP and UDP port numbers of active connections to different things. Okay, so these are different things that are different sessions that are running and so forth. And if I come back up here, I can even look at some Ethernet statistics of. So I can do Netstat-E and say, hey, I just want to see the network's Ethernet statistics. Or, and I'll look at this one last here, I think it was the displays protocol statistics -S. So we'll do Netstat-S, and this shows all the different types of protocol traffic, including IP4, IP6, and those sorts of things. So if we were doing, and actually here's ICMP version 4 versus ICMP version 6. If you remember in the previous lab, we actually did a few of those. So this is gathering statistics on all that. Really handy tool to use to find different pieces of network statistics on our machine. Now, I had you, in the lab, I just have you do Netstat to see network statistics. Okay, we can grab that, but keep in mind all these other little options I was showing you, all these other little extensions, if you will. So I'm going to copy that. I'll do my enter key to copy that. I'll open up my text file from before, and I'm going to add that to the bottom down here. Here was my ARP that I had done previously. I'll come down here to the bottom. I'll hit the enter key a couple times, and I'll do paste of my Netstat. There it is right there, and I'll save this guy. Well, if we did it on Windows, we're going to come over here and do it on Linux, right? So I'm going to minimize all this. I'll come to my Linux virtual machine, and on this one, if I do man Netstat, this gives you the manual on Netstat, which is kind of the same thing as I saw before. This shows me all the options in here as well. Spacebar will give it to me as well. -D, -I, -M, -S, okay? And over here is a bunch of the things we're listening, program, timers, continuous, all that kind of good stuff. There's lots of options. Q will get me out of that. In this case, I'm going to have you do a Netstat, and I'll do -TUAN. And this will look kind of similar to what we did over on the Windows side, where we're seeing what particular sessions are open to what IP addresses and what ports. So this was similar to what we did on the Windows side. We just had to use the extension of -TUAN. So again, I will copy this guy. I'll do an edit. I'll do the long way on this guy because I think that worked best. Edit, copy. I'll open up my folder here. And there's my Chapter 3 Linux. I'll scroll down, and I'll do Control-V and save this guy. So I have him for submission later. So there's a little bit about my Netstat. Okay. Next part of the lab, we're looking at doing some trace. So I'm going to use our trace command on both Windows and Linux. I'll start with Windows over here, and we'll use our trace command to, actually let's do a clear screen over here. We'll do a trace to google.com. So I'll do a trace RT to google.com. and this is going to run a trace out to Google. Now, it's a good possibility things at the network or the edge of the network, things like firewalls or gateways, might be stopping our results from getting back, but we'll let it run a minute and we'll see what we get. What this is going to do is this is actually going to send a packet to each stop along the way and try to learn what it can and hopefully get that information to come back to us. So what we're getting is almost a printout of each step along the way till it gets to its destination. Now, chances are we've hit the firewall or gateway of the network, and it's going to start saying, no, I can't give that information, or certain pieces might not be able to give that information. But we'll let that run a minute, and this should be mapping my path out to, in this case, google.com. Now, where this really comes in handy is if you are working on a network. Again, let's think we're working on Hack's network, and we're sitting in Lancaster, and we're trying to figure out a connectivity issue up to Harrisburg. I can run a trace route up here to a node up here at Harrisburg and see the path it takes and see if it fails somewhere along the line. If it fails somewhere along the line, that's giving me an idea of where the problem might be. Now, it could be a couple things that's causing it, but if I see that, I get this far and no further, maybe this next step that would be here is where the problem is. That's where the trace route becomes really handy, when you do know the path it should normally take. So I've let that run a little bit. It might finish out. I don't know. It might time out. Well, I'm going to do a Control-C just to stop it. I don't need it to keep running. That's fine. I get the idea. It's literally trying every hop along the way to get there. That is using trace or trace route on my Windows machine. Again, I'll copy that, hit the Enter key. I'll open my little notepad file here that I've been gathering stuff in. And I'll come down here, hit the Enter key a couple times, and I'll paste this guy in. I will paste in my trace, and I will save that guy. So there's trace on my Windows. And I also have the option to do what's called a path ping. I'll do path ping, and I'll try hack.edu and see if I can get that guy to work. Now, what this is going to do, with trace, it just tried, like, each step along the way. It's like, are you there? Okay. 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 Path ping is going to try to do this continuously to try to give us some data, kind of like some average data over time on how to get to that destination. So again, we'll try to let that run, see if it can pick that up. We'll let it run a second, see if it's going to pick it up. And it's going to try to build us some data over time. Well, while that's doing, let's be efficient. While that's running over there, I'm going to do the same things on my Linux machine. So I'm going to come over here, while I'm letting the Windows side run. And over here, instead of trace RT, I'm actually going to type out the whole command trace route. And just like before I did trace route google.com, I will do the same thing over here. And this will be a trace to Google from my Linux machine, my Linux VM. So there is my trace running on the Linux. I will kind of spread that out a little bit so we can see the results better. And we'll let it run a little bit. Again, it's probably going to time out as we get so far, but that's all right. We'll try to let it run. And again, on my Linux machine, I'm going to copy all this and save to my notepad file after it runs a little bit. So we're getting there. Again, this is helpful if you know the path it normally takes. And there it looks like a pretty full trace to Google. But this is only a one-time deal. This is like, okay, right now in time, this is the path it took and this would happen. I might need to repeat this a couple times to see what's really going on. But this would be, it's a one little check, one little, kind of run down the road to see if it get there and what path it took. Well, like the Windows side, I will highlight all that. I will do a copy on this guy. I will open up my little notepad file under Documents here. Hit the Enter key a couple times here at the end. I will paste that guy in and I will save him too. There's my trace. Okay, so there's my trace route on my Linux machine. The other thing we can do on Linux is we can actually do, we installed MTR, my trace route. I can run that over here. So I'm going to try to run my trace route to, I think we did hack.edu, so I'll do the same thing here. My trace route to hack.edu. And here's the trace running. Let me make this a little larger. This actually opens up a little GUI, a little graphical user interface. And it's now running a trace to hack.edu, and then it's repeating it 11 times, 12 times, 13 times, 14 times. It's continually tracing and building me some real-time statistics of the last time it went and the average. And this is what I really want to know. I want to know what's the average time it's taking to do this over and over again. So this is continually repeating the data for me and showing me the average over time. Now let's see if our windows over here ever continue to. It's like it's working on it. It's taking its grand old time over there, but it's working on it. There we go. It's getting there. So the path ping and my trace route are trying to do the exact same, or they're actually trying to do the same thing, the same kind of results you're getting between path ping and my trace route. Windows over here did it for looks like almost 2 minutes to build some average time for us. It looks like it's building those statistics, so we'll give it a couple seconds to do that. As I watch Linux over here, it's continually doing it over and over again, 63 times, 64 times, 65 times. So this I would maybe let run for a minute or two, and it's going to build me a good average of the time it's taking, and I can see where the delays really are if I'm having connectivity issues. That's what this is about for me. That's what this is able to do for me. All right, Windows, you can get there. You can do it. Alright, so instead of making you wait and watch for about like 30 seconds there so far, I just paused the video. Here the Windows Trace path ping, if you will, completed, and it showed me some statistics of tracing to hack.eu, the address it took and the time it took to do that, building me some average statistics. I've left the Linux one run over here. I have not stopped it yet. It's gone 178 times now. So if I do a stop on that guy or pause, again, this is building me some average statistics over time that I could use for helping find where a problem is in a path from A to B. Alrighty, so there was using our trace and trace route, and we saved the trace RT results for Windows. We saved the trace route result for Linux, and we even ran the path ping and the MTR just to see what those utilities are about. So at this point, what you want to do is make sure that you have all your pieces. Make sure you have your Windows three-way handshake, IP4 ping, IP6 ping, and then this little text file with the ARP, Netstat, and trace route in. And the same thing on Linux. Make sure we didn't do any of these packet capture things over there because we were doing on Windows, but make sure I have your text file with ARP, Netstat, and trace route in. So what you want to do at this point is log into D2L from your Windows side, submit these files, log into D2L from your Linux side and submit this file, this text file. Do make sure you have all those and make sure they're submitted. And then when we're done here, we can, I'll close some of these utilities out, power down the VM, I can close this out and shut down our Windows machine. So there's our Chapter 3 lab.